All right, folks, welcome to week 3, terminal velocity. So terminal velocity is the velocity, the maximum velocity, the fastest you can go of an object as it moves through a fluid. Now, normally we're talking about the fluid being air. And this is when the force that is being pushed down on them by gravity is balanced and equal to the force of the fluid pushing up, like wind resistance. At that point, you reach a speed and you stay at that speed. That would be terminal velocity. And one of the best examples is a skydiver. So we see he jumps out of the airplane and gravity, the lower green arrow, is pulling him down. And you'll notice that it keeps pulling him down at the same rate. Gravity doesn't change and your mass doesn't change. So the force of gravity will stay the same. But when he first jumps out of the airplane, there's no force stopping him. So he's accelerating. And then we see a small green arrow appear. That's the wind pushing against his body. But at first, it's not that strong. But as he goes faster and faster, the wind is pushing harder. And eventually, the two forces are equal. And at that point, he's still moving, but he's moving at a steady speed, about 120 miles an hour. Now he pulls the parachute, and the parachute opens up and catches more air. So look how big the arrow got. The force from the air is now greater than the force of gravity pulling him down. That's not going to cause him to go up in the air. It's going to cause him to change his velocity. He's going to slow down. He's going to accelerate, negative acceleration. He slows down, and as he slows down, there's less air pushing on the parachute. So that arrow gets smaller, and eventually they balance, and he's now going at a constant speed again, but it's a lower constant speed than it was before. His new terminal velocity is less than it was before. Different objects can have different terminal velocities. This poor little cat here that somebody strapped a parachute onto has less terminal velocity than, say, a bowling ball going down because the air catches it more. And this shows how the terminal velocity changes from when the parachute opens to when he was just falling by himself. Projectile motion is the predictable motion, the path that an object takes once it is launched, whether we're talking about firing out of a cannon or shooting a bow and arrow or throwing a football. Once it leaves whatever it is that launched it, gravity is going to affect it. The angle that you throw it at will also affect it, and it goes in a very predictable path. It goes in what we call a parabola, curved pathway. And what we've seen is 45-degree angle is the best one that will get you the furthest. If you go at less than that, it's just going to go up in the air and come right down in front of you. And if you go lower than that, it'll just drop in front of you. And if you want to drop something out of an airplane and land right, you don't drop it over the target. You have to drop it before the target because you know that it's going to continue in that path. It's going to have the speed from the airplane as it's dropping. So you have to take into account that when you try to drop a bomb or supplies, depending on whether you're trying to kill people or feed them. Next, we have inertia, and this is a very important concept. We'll spend a lot of time with that. Inertia is the resistance of any physical object to a change in its velocity. Newton's first law states this well. An object in motion remains in motion. An object at rest stays at rest, unless some unbalanced force acts on it and causes it to change its motion. Inertia means that things that are not moving will never move unless something causes them to move. And once they start moving, they won't stop unless some force acts on them to cause them to stop. Now, this is real important in a car accident. You're going 60 miles an hour and your car hits a wall. The car stops because the wall put a force on it, but you did not hit the wall, at least not at first. You're still going 60 miles an hour. If you're not wearing a seatbelt or have an airbag, you will fly out of that car until you do hit something that will put a force on you that will cause you to stop. It's the reason why if you run and try to knock an elephant down, it's not going to happen. Objects that are bigger have more inertia than small objects. It's also how this trick works, where you have a coin on a card, and if you pull the card away real fast, the coin just drops right into the glass. The coin doesn't want to move because there's really no force being put on the coin. It's going to stay right where it was. I like this. He put colored chalk on a trampoline and jumps on it, and you see for a brief moment, the chalk kind of stays in the air before gravity pushes it down. So inertia's got a lot of cool things that it does. Poor hamster here wants to get off the wheel, but the wheel's still spinning, so yeah, he starts spinning with it. Mass. This is a concept that is easily confused with another idea, weight. Mass is a really important concept. It is the amount of matter in an object. The more atoms it has, the more mass it has. And a lot of people confuse mass and weight. It's on Earth, they are pretty much the same thing, but they really aren't. Weight, mass is something you have no matter where you go, but weight depends on gravity. Gravity pulling on the mass will give you weight. We measure mass in grams and kilograms. If you go into outer space, you still have the same amount of mass that you had before, but you don't have much weight because there's less gravity up there. So very important to understand the difference between the two. Weight is force on mass. Mass is something that an object has and doesn't change. So how can we measure mass? We do it by comparing an object to other objects that have a known mass. So I want to know the mass of this top here. I put it on a scale and I keep adding known masses to the other side until they balance. So this one weighs 126 grams because that's the amount of mass that balances it out. Now, on Earth, you could say your weight is 560 newtons. You take your mass and multiply it by gravity and you would have your weight. On the moon, you still have the same mass, 56 kilograms, but your weight on the moon is a lot less. It's only 90 newtons. Why? Because the moon has much less gravity. The mass stays the same, but the gravity pulling on it is less, so your weight is less. So let's talk about weight. The weight of an object is the force acting on the object due to gravity. It is the force of gravity on a mass. So when you weigh yourself, what you're really weighing is gravity pulling on your mass. The more mass you have, gravity doesn't change, but the more mass you have, the more you weigh. And we use various objects. Spring scales are a good one, or the scales you step on, and they are simply measuring the pull of gravity on your mass. Is a little bit like inertia, except it only deals with things that are moving. Inertia is both moving and not moving. But momentum is a property of a moving object and it uses the formula momentum equals mass times velocity. So you take the mass of an object and multiply it by how fast it's going and you have momentum. Momentum is describing how much motion an object has. The bigger it is, the more mass it has, and the faster it's going, the more momentum it has. So as an example, if this small truck hits this big, massive truck, the small truck is going to get pushed in the opposite direction, even if they were going at the same speed. The bigger truck had more momentum. If you've ever fired a rifle, it kicks back, but it doesn't kick back nearly as fast or with as much force as the bullet coming out the other side because the bullet has much less mass. Greater velocity, but less mass. Now, the two actually equal out. Law of conservation of momentum. Anytime you see the law of conservation of anything, it says that this thing, momentum, is neither created nor destroyed. It can only be transformed or transferred from one thing to another. So in the Newton's cradle here, when the one steel ball comes down and hits the others, its momentum transfers through all of the steel balls until it gets to the other side, and the one on the far side goes out and then comes back and hits it. And this can go back and forth. It would go back and forth forever if it weren't for friction causing the system to lose energy, and eventually they stop. But if there were no friction, it would just go on forever. You see this when you play pool. You hit the ball and the ball hits a bunch of others, and the momentum of the one ball is transferred into the others, causing them to go flying off on the table. A balanced force is when you have two forces acting in opposite directions on an object, but they're equal in size, so they cancel out. And in this case, the object will either not move at all, or if it's already moving, it will stay at that speed forever. Unbalanced forces cannot change the motion of an object. So here we have a car. It's moving, the engine's giving it a force of 10 newtons to the right, and friction on the wheels is going in the opposite direction, also at 10 newtons. Now, you might think the car's not moving at all, but we said it is moving. It's just not changing its speed. It's not speeding up or slowing down. Now, if I were to press on the brakes, suddenly there'd be more friction, So the force pushing it to the left would be greater, and it would change the car's motion. It would deaccelerate. It would start slowing down. Again, these are examples of balanced forces. As long as these people are either pushing or pulling with equal force, the object will not move. If one of them gets tired and it has less force, they'll move in that direction. So we talked about balanced forces. Now let's talk about unbalanced forces. These are forces that can change the position, speed, or direction of an object. In other words, unbalanced forces could cause acceleration. This is when the forces, when you add them up, don't cancel out. And therefore, they can cause the object to accelerate in one direction or another. Remember, acceleration is a change in velocity. So here's a rail car. It has 8 newtons pulling it to the right and 3 newtons to the left. That's not balanced. So this car will accelerate toward the right and will continue to accelerate until the forces on both sides are equal. And let's go back to our classic, the skydiver. Jumps out of the plane, and at first, gravity is pulling him down. That's the red arrow. And the blue arrow is the air pushing against him. And at first, they're not balanced. So he's going to continue to accelerate and go faster and faster and faster. But the faster he goes, the more the air is pushing against him. You know, if you stick your hand out a window, you can feel that air pushing against you pretty strong. Eventually, they become balanced. And at that point, he has reached terminal velocity and will stay at that speed all the way down until he either hits the ground or pulls the parachute, and things change at that point. But at that point, they're balanced and terminal velocity will happen. So you can see how all these things tie in together. And that's our vocabulary for this week. So watch this again and get ready to take that quiz. Thanks a lot. Bye.